Hello and welcome back to the AI Research Roundup. I'm your host, Alex. Today is May 2nd, 2025. We're looking at an interesting ICLR conference paper titled Diffusion-Based Planning for Autonomous Driving with Flexible Guidance, published just over 3 months ago on January 22nd. This paper tackles the challenge of making autonomous driving more human-like and adaptable, particularly in complex situations where current learning methods often fall short. They propose Diffusion Planner, a novel approach using diffusion models. Alright, let's look at how this Diffusion Planner is actually built. This diagram shows the model architecture. It starts by taking in the scene context, other cars, lanes, navigation info. An encoder then processes this using MLP mixers and attention mechanisms. The key part is the decoder, a diffusion transformer, which iteratively refines a noisy plan into a clear trajectory, like you see in those denoising steps on the side. Okay, so how does this diffusion planner actually perform in practice? This table lays out the closed-loop planning results on the challenging new plan dataset. It compares their approach against various rule-based and other learning-based methods. You can see Diffusion Planner, even without rule-based refinement, achieves really strong scores, like 89.19 on Test 14 NR, outperforming other learning-based planners. It really holds its own, setting a new benchmark for learning-based approaches. Building on that strong performance, this table shows results on a different challenge, a new delivery vehicle driving dataset. Again, Diffusion Planner is compared against various types, and you can see it scores 92.08, significantly better than other learning-based approaches like Plan TF or Pluto without refinement. It also achieves perfect scores for drivability and progress here. This really underscores the model's robustness and ability to transfer well to different driving data. Now let's look at a visual example. This shows a tricky narrow turn. We see Diffusion Planner compared to Gameformer, Plan TF, and Pluto. Diffusion Planner's generated trajectory looks quite smooth and close to the ground truth, that blue line, especially compared to Pluto's paths there. It really gives a sense of the high-quality planning and stability we saw reflected in those strong performance scores. Okay, and beyond just generating those smooth paths, this next visual really digs into the flexible guidance feature. The top plots show how enabling speed guidance adjusts the vehicle's speed profile over time, making it follow that target speed limit. And then the bottom plots illustrate comfort guidance. Look how the longitudinal jerk is significantly reduced when comfort guidance is added on top of collision avoidance. This really highlights the runtime adaptability. So we've seen how guidance can refine the plan, and this figure further explores the planner's inherent flexibility. It shows the multimodal planning behavior. See those light blue lines? That's the model generating multiple possible paths through repeated inference without specific guidance. Compare that to the dark blue line, which is conditioned on navigation. This really demonstrates the model's ability to capture the diverse, yet plausible, ways a human might drive in this scenario. Alright, so wrapping up our look at Diffusion Planner. The key takeaways are really its strong performance, achieving state-of-the-art results without rule-based refinement, and its impressive flexibility. We saw how it handles multimodal possibilities and adapts via runtime guidance. It truly represents a significant advance for learning-based autonomous driving planners. Thanks for joining the AI Research Roundup. I'm Alex.